the atomic, oh, not the ion, sorry. What's the atomic weight of sodium?
22.29.
About 23. We could measure out 22.999, but let's just call it 23. Okay, everyone sees that on their chart? The atomic weight of sodium is 23. If I were to take 23 grams of sodium in that pile of sodium, there would be 6,022. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Uh-oh, did my commas wrong. There we go. That's how many atoms of sodium there would be in that pile. All right, let's take chlorine. What's the atomic weight of chlorine?
34.5.
We'll say 35.5. Or is it 34.5? I think it's 35.5.
35.5.
All right. If we were to take 35.5 grams of chlorine in a pile, that's how many atoms of chlorine there would be in it. Okay, it's just another way of measuring. Instead of saying there's 16 ounces in a pound, well, there's 6 times 10 to the 23rd atoms in a mole. So we can see how many molecules there are. I mean, these are, you can't see them with a microscope. You can't see them with an electron microscope. They're so tiny. All right, what's the atomic weight of uranium? 238. So if we took 238 grams of uranium, it would be a big pile, and it would still have that many atoms in it.
I do not understand. Like, I don't understand. It's supposed to be multiplying this?
No, we're not multiplying anything.
So no. So all these basically are going to have that many.
Yeah. All right. So let's take carbon. If we took 12 grams of carbon, there would be 6 times 10 to the 23rd atoms of carbon. If we took, there's iodine. If we took 120, I can't quite see upside down, 127? 120, if we took 127 grams of iodine, that pile of iodine would have 6 times 10 to the 23rd atoms of iodine in it.
The 6 times 10 to the 23rd is just it's a shorter version of that.
Yeah, or is that what's screwing you up?
No,
All these zeros?
we're just wondering why it was a change. Why everything has 1 mole.
Because isn't that cool?
Yeah.
That's a unit of figuring.
What? And no, that's confusing. Because I don't understand. I understand what a mole is. 6 times 10 to the 23rd is 1 mole, right?
Atoms.
Atoms?
Atoms or molecules. Count them. So if we weighed out 23 grams of sodium, you could sit there and count how many atoms of sodium. But you don't have to. As long as you've weighed out 23 grams, we know there's 6 times 10 to the 23rd atoms in that pile.
Because it's set at atomic number.
Atomic weight. It's set on the atomic weight.
Oh my gosh, I get it now.
Ding! I was just waiting. I thought if I just kept talking at some point.
I get it. Yeah, I get it.
All right, do y'all know what quail eggs look like? Do you know what ostrich eggs look like? All right, if we did a dozen quail eggs, they would fit in this. If we did a dozen ostrich eggs, they would fit in this. But there's still a dozen.
Yeah.
Okay. It's still a mole. Regardless of how big the atom is, it's still a mole. Okay, more confusion.
Is it like a ton of bricks and a ton of feathers?
It's still a ton.
It's still a ton.
Mm-hmm. It's just there would be a different number in that
Right,
case.
right.
It's not quite as good of an example, but.
A ton of bricks is like 23 bricks. A ton of feathers is 230.
38 feathers. But they're still, yeah, a unit. Just different ways of expressing a unit. Okay, okay. Did the eyebrow thing, and I wasn't sure what that meant. I need to check. All right, I have for you a mole of salt.